Hello and welcome to Chapter 14. In Chapter 14, we are going to work on correlations. This is a form of bivariate relationships, so it's similar to what we did last week with the crosstabs, but it's a little bit more sophisticated in that with correlations, we can actually start to determine both the direction and the strength of the relationship. The crosstab functions that we did last week were pretty basic. We don't do that a lot in the research. Rather, we use Pearson R. We use gamma and lambda at times. That's in chapter 13, which we've decided to skip, or I've decided to skip with you guys. But with bivariate relationships, particularly with the Pearson R, we can actually start to determine how related two variables are together. If you noticed in the Canvas module, there are quite a few PowerPoints. Those PowerPoints walk you through step by step some of the statistics that we are going to be covering in this unit. There's a lot of numbers, a lot of symbols and whatnot. Try not to get too overwhelmed or too nervous about this section. Most of the stuff that you see in those PowerPoints, SPSS is actually going to do for you, going to compute for you, and you're just going to have to interpret. However, on those PowerPoints, I wanted to let you guys see what was going on behind the scenes in SPSS. So exactly how was SPSS computing these numbers? So again, when you're going through those different PowerPoints, don't get too stressed out or don't get too tripped up on the formulas and all the numbers because you aren't actually going to have to do that. SPSS is going to do that for you. So let's get into the meat and bones of Chapter 14, Correlation and Regression Analysis. You will see that we revisit regression analysis next week with more than two variables, but this week we're just going to focus on regression analysis with two variables. So if you read Chapter 14, you'll see the very beginning. They kind of lay out what a Pearson R is. Again, it's a bivariate measure to determine how related, how strong, and the direction, whether it's a positive relationship or a negative relationship between two variables. Remember from the PowerPoints, a positive relationship means the two variables move in the same direction. So for example, as age increases, we'll say crime increases. So they go in the same direction. On the other hand, let's say that as age increases, crime decreases. That would be a negative relationship. So as one variable increases, the other variable decreases. So the Pearson correlation coefficient lets you determine that. Also, a couple things to know with Pearson correlation coefficient, it has a range. It ranges from -1 to +1. -1 is the strongest possible negative relationship that you can get. So again, meaning as one variable goes up, the other variable goes down. +1 is the absolute strongest positive relationship that you can get. So again, both variables move in the same direction. So as number of delinquent peers go up, the likelihood of juvenile delinquency goes up. 0, right in the middle, means that there is absolutely no relationship between the two variables. And as you get closer to those extremes, -1s, the stronger the relationship. And as you get closer to 0, the weaker the relationship. You will see in the PowerPoints that I give you both the hard sciences rules when it comes to strength of relationship as well as the social science rules when it comes to strengths of the relationship. You will notice in social science that the strengths of the relationships are quite smaller than they are in the hard sciences. That is because we're dealing with human behavior and many factors come into play when determining human behavior. So if you look on page 240 of your book, you'll see kind of that same graph that is in the PowerPoint section for correlations about what is a weak, moderate, and strong relationship. So with correlations, what you'll see generally that, again, no relationship is 0, a weak relationship is 0.01 to 0.09, a moderate relationship is 0.10 to 0.29, and anything over 0.3 is a pretty strong relationship. So as we work our way through the chapter, you'll see at the beginning, they're talking about what are some variables that could be related, how could we do a Pearson R. So they look at height and weight. So what they're examining is that if you know somebody's height, can you predict their weight? And is there a relationship between the two? And we will find that there usually is a relationship between height and weight. Generally, people who are taller weigh more. It's not a perfect relationship. It's not a point or a 1.0 relationship. In fact, if you look at the book, it's a 0.34 relationship. You can find that number on page 239. So if you go off that chart that's both in your PowerPoints and in the chart on 240, we can see that's a pretty strong association. So knowing somebody's height helps us predict somebody's weight quite accurately. So let's actually get into SPS and how we calculate this through SPSS. If you notice through on page 240 of your book, they ask you to recode income. This is very tedious recoding to do. There's actually 25 categories that you'd have to recode. And so I have gone ahead and done that for you. So as long as you've opened the chapters 14 and 15 data set, that recode has already been done for you. You guys have recoded multiple times. You've recoded on quizzes. I didn't think that you guys needed to spend the time to recode once again. So you can kind of skip to page 244 in your book, and that recoded income has actually already been done for you. So now let's actually measure or create a bivariate correlation, particularly the Pearson's R. So in order to do that, one thing we have to make sure first is both of our relationships are metric, or meaning that they're interval and ratio level data. So remember we had nominal, ordinal, and then I combined the interval and ratio together and called them metric. Nominal and ordinal variables will not work in a regression or in a Pearson's R analyses. So you have to make sure that you know the level of measurement with your variable and that both of them are either interval or ratio level measures. So the book we're going to follow along with would like you to actually determine the correlation between age and that recoded income measure. So how we do that is we go to Analyze. You'll come down here, you will see there's a Correlate button. And from the Correlate button, you'll click over onto Bivariate relationship or Bivariate. You can see where I was working through this before. Let me kick some of that out and I'll start it all over. Your guys' data set may come up where it looks like this. Remember, if it looks like this, if you actually have the variable labels here, you can click over here and have display variables name. Right click that way to get display variables name. You can also right click again and have it sort alphabetically. So we want to correlate age and the new recoded income measure, which is RECINC. Right? Before we click OK, we want to come over to options. We want to make sure that we have checked exclude cases pairwise. By doing this, we are able to give ourselves the most use out of our data. So if we had missing values on one of the variables, we can still go to correlation versus if we did listwise. So click continue and then click OK. And you will see a correlation table comes up or correlation matrix comes up, right? So real quick, how to read this. You will notice that in any correlation table that you do, there's always ones down the diagonal. And the reason for this is you're correlating the one variable with itself. So in this box right here, we are correlating age of the respondent with age of the respondent. And since it's the same variable, those are perfectly correlated with one another. In this box down here, we're correlating recorded income with recorded income. On the off diagonals over here, you will start to see the actual bivariate correlations. So in this box, we are correlating age of respondent with recoded income, and the same thing is happening in this box, age of the respondent with recoded income. And this first number you see in this box, if you follow along here, is the actual correlation that Pearson's are. So that is 0.209. What you will notice, and this will come into play on the next chapter that we go through, you'll see the little stars. That means that this is a significant correlation, a statistically significant correlation. So this correlation is not due by random chance, that there's actually a true correlation or a true relationship between age of the respondent and their subsequent income. It's 0.209, so if you go back to our chart that was on page 240, 0.209 says that it's a moderate relationship. So it's a moderately strong relationship. It's also positive. So this means that as the age of the respondent increases, income also increases because those variables are moving in the same direction. Another way to tell if this is significant besides the stars, if we pop down to the next line, is this value right here. This is the significance level. If that significance level is less than whatever you deem as a significant level, it's usually 0.05 or 0.01, then we consider that variable statistically significant. So if it's less than the agreed upon or what you set as your significance level, it is a statistically significant variable. This last number is just the N. That is how many cases. So we had 853 pairs that we were able to make a correlation between age of the respondent and their subsequent income. So again, what's really important in these tables basically is just this first line, because this first line pretty much tells you everything. This tells you the correlation, this tells you if it's positive or negative, and it also tells you, because of the stars, if it's statistically significant or not. Another kind of unique thing that we can do in order to determine a correlation is if we have many variables that we want to see if they're correlated, we can put them all in the same box together or the same matrix together. So how we do that is we just go back to Analyze, come down to Correlate, go to Bivariate, and then what you're going to do is add education level here. So click there. So you will see now that there's 3 variables here. Click OK. The options should stay the same, the pairwise. Click Continue, then click OK. And you'll see we now have a larger correlation table. Let me expand this real quick for you guys. You will see, again, the ones are down the diagonal. Again, the ones are down the diagonal because you're correlating the variable with itself. So the first box is age of the respondent and age of the respondent. Then you have recoded income, and then highest year of school completed and highest year of school completed. Again, across the top, you see the Pearson R, the significance level, and the N, or the number of cases. Recoded income and age stay the same because we're just correlating them. So you'll see recoded income and age, and recoded income and age here is that same as at 2.09. But now if we look at highest year of school completed and age, you will see, which would be this box here, you will see that it has a negative correlation of 0.042. So that is a relatively weak relationship according to our standards. Also, you notice that there's no stars next to it. That means it's a non-significant relationship. So this relationship could be happening by chance. We wouldn't take much stock in this relationship. In fact, we would say that age and highest year of school completed are for all intents and purposes, unrelated. You also see that this is a negative correlation because of the negative sign in front of this. So this would mean if this would have been a statistically significant relationship, this would have meant that as age increases, as people age, that the level of their education decreases. Kind of doesn't make sense, but that's okay because, again, this is a non-significant relationship because this value right here, this 0.105, is greater than 0.05, or our significance level. So you'll see that there's no stars here. So that's how you do a correlation when you have 3 different variables. Now you can put 3, 4, 5, 6, 10, 12. You can put as many variables in here. Again, you just have to make sure that they are all interval or ratio level variables and not nominal or ordinal variables. You will see, in the book alludes to this as well when we get to the next section, that if you ever want to explain how much variance or how much difference in the dependent variable is explained by an individual independent variable, what you do is you come in here and you square this number. And by squaring, I just mean you multiply it by itself. So we would argue that age of the respondent can actually explain 4.4% of the variation or the differences that you see in people's income. So that would be a way to kind of determine that. Another relationship that we see here is recoded income and highest year of school completed. And you'll see this is an extremely strong relationship. It's a 0.409 relationship. It's positive, so that means as recoded income increases, highest year of school increases. You will see it's significant because 1, it has the stars, and 2, you have the 0.000 here, which is less than 0.05. In fact, it's less than 0.01. So we would say this is a highly strong relationship between recoded income and high school, highest year of school completed. And in fact, what we would probably say is that as highest year of school is, as you have more schooling completed, your income is more likely to increase. And if you wanted to know how much that, years of school impact the income, you would square that 0.409, and that gives you 0.16. To get a percentage, you just move the decimal place over 2 places to the right. And so you could argue that, or you could state that 16.7% of the differences that we see in income can be explained by individuals' highest year of school completed. The book then goes on to give you another way to determine coefficients or determine the Pearson R. These are not very common ways to determine the Pearson R. What you guys just did here with the correlation matrix are the most common ways and actually my preferred way. But I will walk you through the regression example as well as the scatter plot example. But again, these are not very commonly used. So regression is generally used for multivariate statistics. It's when we're trying to control for multiple variables. So we might have 3, 4, 5 variables in a model that we're using to predict an outcome. And so a lot of times in order to do the statistics right, we have to do what we call a regression. With bivariate statistics, it's kind of silly to do a regression, but just to kind of give you a taste of regression, which we'll do next week, I'll walk you through this. And again, a regression gives you, if you guys remember how to make a line, remember y equals a slope, a constant plus a slope times a value. You'll see that on page 252. The regression coefficients or the regression way to do statistics actually gives you the equation there. But again, it's kind of silly to do with bivariate relationships. So how you would run a regression if you were trying to determine, the correlation is you would run down here or hit analyze, run down to regression, go to linear, right? Kick these over. Oops. It over on the wrong way. You can see where I was working through this before. But now what demonstration 14.4 in the book is having you do is they want to predict your current level or the respondent's current level of education, that is their dependent variable, by knowing that respondent's parents' education. So is there a correlation, is there a relationship between how educated a person's parents are and their subsequent education? So you would put independent variable is your parents' highest years of schooling, and then the dependent variable is the respondent's education. You want to click over here in options, and you want to make sure it says exclude cases pairwise. Usually the default is listwise, so when you guys run this, you may see that it is listwise. So again, you want to make sure that says exclude cases pairwise. Click continue, click OK. Forget that first box, doesn't really mean anything. You'll see in the second box, it gives you the R. And remember, the R right here is the Pearson correlation coefficient. So you get 0.490. That is a very strong relationship, so in a positive relationship. So because it's a positive relationship, it means that as a person's parental education increases, their subsequent education also increases. So there is a link between somebody's parents' education and their own education. The R squared, remember, is just telling you how much of the difference that you see among people in their education is explained by knowing their parents' education. And so about 24% of people's of the differences that we see in people's educational attainment can be explained by knowing their parents' education. And again, the 24% you get is just by moving the decimal over 2 places. Don't worry about the adjusted R squared yet. That will come into play next week. Also, the ANOVA, this will come into play in the next chapter. Wait till you guys see, and you may have already watched or gone through the PowerPoint for ANOVA. The statistics behind the scenes for the ANOVA are quite hairy, actually. They're quite intensive. So it's really nice that SPSS does this very, very quickly and gives you this nice little table that you're seeing right now. Now, what regression tries to do is fit a line. And so you will see these regression coefficients right here are the numbers you need in order to create a line. And so in order to create a line, there is a equation that describes a line. And so it's y, or the dependent variable, equals some type of constant. And so you will see the constant right here is 9.360 plus a slope times the value of an independent variable. So the slope is b and the value of the independent variables are x. So the slope, the b, is this value right here, this 0.361. And that is what you can do if you want to know a specific value of the dependent variable, if you know a value of the independent variable. All you would do, and if you follow along on page 252, you could see this. If you wanted to know what the value of someone's education, their respondent's education would be if the parent had a 12 years of education, you would just enter in this equation, y equals 9.306 plus 0.0361 times 12, or the value of your independent variable. And you would see that somebody who had parents with a 12th grade education are likely to have 13.638 years in education. So you can kind of tinker with that and change the independent variables and see how that impacts the dependent variable. Again, we don't really do this. This is kind of silly to do it this way. It's much easier just to, put that correlation matrix together, and it's pretty easy to interpret it that way. The last way that the book shows you how to present data is with a scatter plot. Again, we very, very, very rarely use this. And a way to do this is, or a reason you may want to do this is if you actually want to see how the line kind of goes together, how the regression line would look. So what we would do in order to create a scatter plot is you go up to graphs, go to legacy. We're going to come all the way down here to scatter and dot plot. Stay at simple scatter and click define. I already had this in here, so I'll kick it back over so you can see it. Remember, x is always, always, always your independent variable, and y is always your independent variable, or your dependent variable. So remember, education is our dependent or our outcome, so we stick that there. And parental education is what we're trying to use to predict somebody's educational outcome. So that goes over here. So again, y is your dependent variable, x is your independent variable. So you come over here. Oops, that moved in front of you guys. Sorry about that. It's moving again. It's not letting me. Click OK, which you guys couldn't see in the bottom of the screen. I'm sorry. And if you scroll down, you will see a scatter plot. And you can see, if you look at the dots, you can see the lines are kind of generally going in this direction. So that indicates a positive relationship. If the lines were going in this direction, or the dots, I mean, that would indicate a negative relationship. And if there was really no kind of pattern to the dots, if it was just all kind of all scattered and the only way you could draw a line through it is if it was completely horizontal, that means there's no relationship. But there is a way to determine if it's positive or negative. So if you double click on the graph, what you can do is the graph will open up in this chart editor. And so a couple things that you can do. I really don't like using the graphs. I don't think SPSS has a good graphic. Good graphic. We never report these in our journal articles. We don't really report these in our books. So I really don't like using this, but as the book showed it, so you guys didn't get confused, I wanted to go through it. They give you kind of a goofy way in order to fit the line, and I'm not sure why they do that. If you want to fit a line in here, if you want them to fit like the best line that would go through these go through these dots, all you have to do is come up here on the toolbar and you'll see add fit line at total. That's all you have to do to click. And you'll see very quickly a line pops up, and that's what goes through. And if you look at that, that line has a positive slope. It's going this way. So that means as the values of x are increasing, the values of y are also increasing. If the line had a slope this way, that would mean it's a negative relationship. So that would mean as the values of x are increasing, y is decreasing. You see we get the same results that we did with the regression coefficient. So you have the y equals the 9.75, right, or the constant. You get very similar results. And the slope is 0.361, and the slope before was 0.36 times x. So again, it shows that it's a positive relationship. If this is a negative relationship, this would say minus and not plus. But that is one way to determine if it's a positive or negative relationship. Also, the more that the line is sloped this way, the stronger the relationship is. The more that you see this line kind of gradually go up, the less steep that this line is, the weaker the relationship is. That is it for chapter 14. If you have any questions, comments, concerns, please email me or give me a phone call, and we will move on to chapter 15 next. Thank you and have a good day.